Hi, my name is Padmasree, a third year student from Kiet-Hub at Kakinada Institute of Engineering and Technology. Today, our topic is representing textual data. Let's go to the topic. Why we use representing text data? Because machine cannot directly understand the human readable text or normal text. It only understands the numerical format or numerical data. This representing text data comes under NLP, that is natural language processing. This natural language processing is used to convert the audio into the text and text into the numerical data, or we can directly convert the audio into the numerical data. Next, we have to learn the main terms of this topic. Ambiguity. Ambiguity having a multiple meanings of a single word. In first example, what's today's date? Here the date means normal date. In second sentence, we I love eating dates for breakfast. Here the dates means it is a fruit. Here the date having the different meanings. It is called ambiguity. Sparse data. The words does not have any meaning but use it frequently is called sparse data. In example 1, the boy is playing, the girl is running. Here, the and is are used frequently, but they have no meaning. This is called sparse data. Expressivity. Same meaning can be expressed with different forms. Here, I am happy, I am not happy. In two sentences, there is happy, but the first sentence is positive sentence and the second sentence is negative sentence. So, it is called expressivity. Next, we go to the pipeline. Pipeline is the process to convert the text into the numerical data. Here we discuss about the pre-processing steps. First step is we have to convert the all the characters into the lowercase. Next step, removing punctuations. Next, removing numbers. After that, we have to do stop words, stemming, lemmatization, HTML tag removal. All these steps we have to discuss in the further. In pre-processing step, we have to clean the unwanted data. Unwanted data means full stops, commas, null values, punctuations. All these are called unwanted data. If we clean the unwanted data, then we get the proper data to convert the text into the numerical data. Next, we go to the pre-processing steps. In this, first convert to lowercase. Why we have to convert in lowercase? Because in this example, cat and the cat, here the first alphabet is capital and here the first alphabet is not capital. The machine does not treat it as both in same way. Both are having the different cases. So we have to convert all the characters into the lowercase. Now we see the practical knowledge of the remove punctuations. Before that, we have to import the dataset. For importing dataset, we go to the files and upload files and give the CSV file of dataset. Open. Then we successfully import the dataset. Now we have to write the code. Here first import the pandas as PD. Pandas is used to manipulate the data. Import strings, manipulating the strings. Import RE to run the regular expressions. Next, DF is a variable which is equals to the dataset. In our dataset, we have two columns. One is ID and text. In text, we only manipulating the data. So we can take only the text. Here, that DF means variable. Df of text dot string. Every string is converted to lowercase. Dot of lower. It converts the every string into the lowercase. So df means it prints the output of the dataset. Now we run our dataset. Here the output. All the uppercases are converted to lowercase. Here there is no uppercase. We successfully convert the uppercases into the lowercase. Now we come to our theory part. Remove punctuations. We have to remove comma, full stops, all of this from the data set. This is called remove punctuations. Now we see the practical part. Here string dot punctuation. All strings is removed punctuations, then it is converted to the strings and then it translated to strings and it stores in the dataset. Now we run the dataset. Here all punctuations are removed. In above, here the punctuations dot, here the HTML tags all are removed from this. Now third one, remove the numbers. We have to remove the numbers from the data set because we do not have any use from that numbers. So we have to remove the numbers from the data set. So we see the practical knowledge. Here dataset dot apply of lambda function. Because of this lambda function, we remove the numbers from our dataset. Here subtract from digits. This function makes the digits to eliminate. So we run the output. Now see, there is no numbers in this dataset. In previous output, we have 2, 3, 1, but in this output, there is no numbers. So we successfully remove the numbers from our dataset. Next, we go to stopwords removal. Stopwords means it is a unwanted words in our dataset or our sentence. For example, the cat is sitting on the mat. Here we don't want the words of the, is, on, the is having no meaning in the sentence. So we can take only the cat sitting mat. Because of this, the, is, on, the are the making the dataset more complex. So we have to remove that stopwords from the dataset. Now we see the practical knowledge. We have to import the NLTK because it is a Python library to use the natural language processing. NLTK means natural language toolkit. This toolkit having some stopwords in English, Hindi, Telugu. So we have to take now English only. From that we download the stopwords. From our data set, we take apply lambda function to remove the stopwords. To removing stopwords in our data set, we have to split every word from the data set. Now, if that word is matched with the stopwords, then we have to remove that stopword. After that, we print our data set. Now we printing our data set. See here, all the downloads are done. Next, here the stopwords are removed. See in this, he, on, the are removed in this output. So we successfully remove the stopwords. Next, stemming. Stemming is the process of getting into the root node, means removing the suffix. Here, the three words are same. Place, playing, play. Here the suffix is s. Here the suffix is inning. So there is no suffix. Here the three words are similar meanings. So we turned it into only play. Removing the similar words. So we take only play. Removing these two words. This is called stem. For stemming, we use Python NLTK inbuilt library. From that, we import poster stemmer. By using this poster stemmer, it has the root nodes inbuilt, so it can eliminate that words in from the our dataset. Here, it's our dataset words are splitted into the different words, and if the stemmer is equals to the our dataset word, then it removes from the dataset. Now we have to print our dataset. Here, see shining. ink will gone. So it's only shine. Here the root nodes are printed. Now we goes to the lemmatization. This lemmatization and stemming are very similar to each, but some small difference between them. Here we remove the suffix of the word, but here we remove the similar words. Here better and good are the same words. Because of that we put only good and we remove the better. So both are giving the same meaning. So we remove the one word from the dataset. This is called lemmatization. Now we're seeing the lemmatization in practical. From NLTK Python library, we import WordNet lemmatizer from inbuilt. We download to to eliminate the lemmatizer words from the dataset. We download WordNet and OMW.1.4 we have to download. Next, lemmatizer is equals to WordNet lemmatizer. Here it is inbuilt having the lemmatizer words in inbuilt. Here dataset dot apply of lambda function. Here lemmatizer dot lemmatize word. If there is a lemmatizer word in our dataset, there is words that words are splitted into the words. If that words are matched with the lemmatizer word, then it removes one of them and it will join to our dataset. This is the process. So we print the dataset, updated dataset. So here it was downloading the root words. So here we get removed the lemmatized words. Next, we have HTML tag removal. HTML tags means paragraph H1 tags. If there is any HTML tags in our dataset, that will remove this HTML tag removal. By using this, we can remove the HTML tags from our dataset. We see the implementation. From BS4, it is a Python library inbuilt. We import beautiful soap. By using this function, we remove the HTML tags. Here we write a function remove HTML tag of text. Here we give the our dataset. This beautiful soap does parse the HTML tags from the dataset. Return beautiful soap of text comma HTML parser. It will parse the dataset, get a text of. Then our dataset is equals to apply of remove HTML tag. It will stored in our dataset. So our print our dataset DF. Now printing our dataset. Before we don't have any HTML tags in our dataset, because of that it gives the same output. But this is the process to remove the HTML tags from the dataset. We use beautiful soap by importing from the BS4. It is a Python inbuilt library. Next we go to the our pipeline. We complete the pre-processing steps. Now we have to do the tokenization of our language. By using this tokenization, we can divide the each word from the sentence. Now we see what is tokenization. Here, the tokenization is broke down a pieces into small units is called token. There are types of tokenization. There are three types of tokenization: word tokenization, sentence tokenization, character tokenization. Word tokenization means splitting the text into individual words. Here I love Python. I is one token, love is one token, Python is one token. Here it will stored in the list format. Sentence tokenization, splitting the text into sentences. Here sentence. Here hello, how are you? It is a sentence. Hello and exclamation is one token. How is one token? R is one token. U is one token. Here, character tokenization, breaking the text into individual characters. Here, cat, C is one token, A is one token, T is one token. This dividing the small units is called tokenization. This is used because of the each character or a word will converted into the numerical format so that we divide into the small units. This is called tokenization. Now we see the tokenization implementation. We have to import NLTK, Natural Language Toolkit. From that, we download the tokenizer of Puncti tab. We have to write the function to make the sentences into a tokens. Return nltk.word tokenize of text. It is an inbuilt function is given to the dataset. Next, df text is equals to df text dot apply tokenized text. It means the word tokenizer function will take the dataset of each sentence and it will divide it into the some tokens in a list. So we print the df. df means our dataset, updated dataset. Now we run the dataset. Here the downloads we have to done in the up in this line. Next, it changes it into the tokens. In last output there is this output. It changes to this output. Uh, in list format, it stores each token. Cat, sat, mat is a three tokens in one sentence. Here four tokens in one sentence. Like that, all the tokens. So it is successfully tokenized the dataset. Now, once we go to the previous pipeline, we complete our pre-processing step and tokenization to get language units. We get the language units. Now we have to do mathematical representation of the language unit. This is the main thing in the representing textual data. After that we build the training and testing data and we train and test the model. We can successfully predict which we want to. So we have to do mathematical representation of language units. It is the main topic in the representing the textual data. They are mainly two types. Uh, Now we see the two types. Here the text representation in NLP are divided into three types, but it mainly two types: statistical encoding and neural networks. This rule grammar based is the previous one which is used in our starting stages of this text representation in NLP. Here, statistical encoding they are discrete space, feature selection, feature transformation. In neural networks, there are feature based and fine tuned based embedding. Now we discuss about discrete space. In this one hot encoding, bag of words, engrams, term frequency, TF and IDFs, we will discuss about these five topics. In next we discuss remaining. So we go to one hot encoding. This is one hot encoding which is under mathematical representation of language units. One hot encoding transforms each word into a binary vector where each word in the vocabulary is represented as a unique vector. Here the example is the cat sat on the mat. Here we can take the each word from the sentence as a token in previously. So we take each word and in columns and row wise. In first, the in this sentence, the first word is the. The in column is one time and the in row will be one time. Here next, the column 2 means cat. Cat is 0 and the is also 0. There is no play. There is no the character in this column. So likewise, all we put cat means cat 1, sat 1, on 1, mat 1. Here we put like this. So by using this matrix we can retrieve this statement. Here we put 1 means the here 0. So there is no any character or a word. Next cat. Next sat. The cat sat on mat. We can retrieve the sentence from the this matrix. This is called one hot encoding. By using one hot encoding, we can do some simple data sets. Done one hot encoding by transferring converting the text into the numerical data. Now we see the implementation of one hot encoding. By doing one hot encoding, we have to take sklearn inbuilt library in Python. From sklearn, we have to take feature extraction dot text. From that, we take counter vectorizer. By using counter vectorizer, we can do the one hot encoding. We can labeling that in the matrix manner. So by taking our dataset, we give the lambda function to join the all our dataset in one place, so that will change in the dataset. Vectorizer is equals to count vectorizer binary is equals to true. If the dataset word will converted into the binary, if it is binary is true, then it goes to next step. If it is not binary, then it is stops in here. Next, x is equals to vectorizer dot fit transform dataset. Here it is a dataset. It will transform to the our old dataset. One hot encoding df, it is a variable is equals to data frame. So after the one hot encoding is done, it will stored in the form of data frames. So now we print the one hot encoding df. Why we have to print this like this? Because the variable we take one hot encoding df is a variable, so we have to recall it. So we type this to print our dataset. Now we have to run the code. So see, basketball, how many of the here previous output, first cat sat mat. Here cat in first sentence and fifth sentence the cat is there. So in first sentence and fifth sentence here the cat is there. So it print 1, remaining all prints 0 because there is no cat in other sentences. So the cat is on first 0 sentence and fifth sentence. So it prints 1 in 0 sentence and fifth sentence. Likewise, next sa. Sa will be in 0 sentence and fifth sentence. So it prints 0 sentence 1 and fifth sentence once. Likewise, all this matrix was built by using one hot encoding. Now we see the next type, bag of words. Means bag of words represented the text as a matrix of words count. Here, for example, the cat sat on the mat. Each character in this sentence will take as a one token in the columns. But in bag of words, we don't take the in column wise. In for single sentence only. The will be the two times in the sentence. Here the and here the. So it have two. Cat 1, sat 1, on 1, mat 1. So this is the bag of words to represent it in the matrix. By this we can retrieve the this sentence, but some mistakes will be done by using this. Now we see the implementation of this bag of words. Bag of words. For this we import pandas as PD from sklearn. It is an inbuilt Python library to make the bag of words feature extraction.text from the sklearn import count vectorizer from the feature extraction.text. df is equals to a variable which is assigned of from the dataset. First, we make the all steps again for this bag of words. We do the convert to lowercase. Next, we remove the punctuations. Next, we remove the numbers. Next, we remove the stop words. After that, vector is equals to count vectorizer. By inbuilt library of sklearn, we take count vectorizer function to make bag of words. X is equals to vectorizer dot fit transform of dataset. It will stored in the X variable. Now bag of words of df is a variable which is converted pandas to data from the data set. Now we print bag of words of df. Now we run the code. By this we get the output. This is the output of the bag of words. We are successfully executed bag of words. Next we go to other topic. N-grams. N-grams are continuous sequence of n items for a given text. They capture context and can help in understanding sequence of words. For example, the cat sat on the mat. In unigram, we can divide it as the cat sat on the mat. In biogram, we can divide as the cat sat on the mat. By using this, we can get the perfect answer. Uh, the diagram: the cat sat on the mat. By using diagram we can get the answer, but the complexity of the dataset will be increases. By using biogram we can get the correct answer. By using the unogram we can't get the correct answer. We see in the bag of words and the one hot encoding. In the same case, we use unigram. By using biogram, we can get the more accurate result to convert the text into the numeric form. In diagram, if we use the diagram, then we get the more complex data set. So that we use biogram to get the correct, and we can retrieve the statement or a sentence from the matrix. Now we implement the n-grams in the code. So import pandas and sklearn library as we take from the bag of words and the one hot encoding. Same step has been done. Here we take the dataset and we convert it into the lowercase, remove the punctuations, next remove the numbers, next remove the stop words, and then this is the main step changes in the n-grams. from the words of bag. In this step, vectorizer is equals to count vectorizer of. In bag of words, we take only the data set. In one hot encoding, we take if binary is equals to true, then it goes to the next step. Uh, in n-grams, we take the range of two words from 2 to 3. We take two range step of the words. Next, x is a variable is equals to vectorizer dot fit transform. Ngram df is equals to pd data frame of to array. To convert it into the array, column is equals to vectorizer dot get feature names out. Now print the data set. Now we execute the ngrams. Only this line changes the entire code. The difference between the one hot encoding and bag of words and ngrams is only this one line. Now we see the output. Here is combined in ngrams. Here every three words also combine in ngrams. So this is the output of the ngrams. So we have successfully generated the ngrams matrix. By using this, we cannot retrieve the statement properly, but it will be give the more accurate result. Next topic we have to see term frequency TF. Term frequency measures how often a word appear in a document or text. It is the ratio of number of times a word appears in the sentence to the total number of words in the sentence. For example, the cat sat on the mat. In this example, the will takes two times. So total characters 1, 2, 3, 4, 5, 6. Total words are 6. Here the is 2 times. 2 by 6 is the term frequency. Next, cat. In the sentence, cat is only one time word. So the count is 1. So the term frequency is 1 by 6. Why this 6 will come means in this sentence there are 6 words. So that 1 by 6. Same as sat. Sat is one time count. So 1 by 6 of term frequency. On is one time. Count 1 and term frequency is 1 by 6. Same as mat. Count 1, term frequency is 1 by 6. This is the term frequency. It is the ratio of the number of times a word appears in the sentence to the total number of words in the sentence. Now we implement this in the code. Now we will execute the term frequencies. Same as above, import pandas and from sklearn we take the counter vectorizer and import strings, regular expressions, natural language toolkit, stop words, NLTK. Now download the stop words. Next, take the dataset, make it into the lowercase. Next, remove punctuations, remove numbers, and remove stop words. Now we build the ngrams here in above. Same we give that code only. Next, from vectorizer dot fit transformer of def dataset ngram df is equals to data frame. Data frame means it is a panda library. From to array, it changes to array. Vectorizer dot get feature name out. TF-DF is equals to ngrams df, where we can generate ngram df. From that we divide the frequently appeared words, we can divide from it. So we can print the TF-DF means term frequencies. Now we run this code. Now it downloads the packages and it runs. It is the frequencies of the given data set. Here some are used more than once. So it is get like this 0.14, like this it gets. This is the term frequencies implementation. Next, we go to next topic. It is inverse document frequency. IDF measures the importance of a word in the entire corpus. Words that appear in many documents has a lower IDF. In this example, the cat sat on the mat. In this, the word is appears two times, so the IDF value is 0. The log of 5 by 5. Why 5 means it appears twice. That's why we have to take denominator as also 5. Why 5 means 1, 2, 3, 4, 5. So that we take 5 is equals to 0. Next, if the appear in all the sentences, it will have a low IDF value, while the cat appears only in few sentences, in a high IDF value. Here we take the example as only one sentence. The cat sat on the mat. The will appears twice in the document frequency. So we give the total number of characters by uh, total number of characters, because log of 5 by 5 it appears two times, so that it gets low IDF value. Cat cat appears only once, so it get log of 5 by 1, so it get 1.6094. Same as all sat on mat, all appears once, so it get high IDF value. If the appear in all the sentences, it will have a low IDF value. Cat appears only in a sentence, result is a high IDF value. By using these techniques, by using these methods, we can convert the text into the numerical data. Now we implement inverse document frequency embedding. Same as one hot encoding, bag of words, term frequency, all the code are same. The changes in only one line. First we import pandas. Next from sklearn we take TF-ID vectorizer. Here we in above term frequency we take count vectorizer, but here we take TF-IDF vectorizer to get inverse document frequency embedding. Next we import string, next regular expression, NLTK corpus stop words, next NLTK we download the stop words, next we assign dataset to the DF, next we convert it into the lowercase, remove punctuations, remove numbers, remove stop words. Next, vectorizer is equals to TF-ID vectorizer of n-grams range. N-grams range, we put a step of each word in the dataset. 2, 3. So xtf-idf is equals to vectorizer dot fit transform with dataset. It will transform with dataset to the TF-ID data variable. TF-ID df is equals to the output will changes to the data frames by using the pandas. xtf-df is to array. It changes to array, and it get from the feature name of out. Now we will execute this TF-IDF DF dataset. Here the downloads stop words packages. Next we get the output. Here the less means it is the low IDF, and here the high 0.4472 and 0.509814. Here all these are called high IDF. IDF means inverse document frequency. This is the implementation of the inverse document frequency embedding. Thank you. Now we repeat all the topics once again. Here first we talk about the representing textual data. Next we discuss about the main terms of ambiguity, sparse data, expressivity. Next, we discuss about the pipeline of pre-processing, converting lowercase, removing punctuations, removing numbers, stop words, stemming, lemmatization, HTML tag removal. In detail, we discuss about this pre-processing steps of each six types. Next, the pipeline of the entire representing textual data from text to the numerical data. In between, we have to done tokenization. After pre-processing, we have to done tokenization. After that, we do mathematical representation of the language units. This is the tokenization. What is tokenization means it divides the each term into a single token, each word into a single token. Next, we discuss about this flowchart text representation in NLP, but we discuss some topics in statistical encoding. Remaining we can discuss in other video. Next, we discuss about mathematical representation of large units, one hot encoding, bag of words, n-grams, term frequency, inverse document frequency. Thank you. If you want any collab links or PDF link, check in the description. Thank you.